Good morning, Pete. Nice early Saturday. Perfect morning for some crazy science. I used to have a whistle that could bring traffic to a stop. Could stop jumbo jets from taking off. Like whistling on the balcony of the departures terminal. Jumbos would, what's that? But now, tis gone. When it comes to whistleblowing, what I'm doing, right, trumps any whistleblowing that has ever. That phone's a bit tilted. What's going on there? Oh, it looks all right from here. That's funny. Anyway, when it comes to whistleblowing, what I'm doing, you can't even compare it to any whistleblowing that has ever been done before, because it's the magnitude of what we're blowing about. Our parents, grandparents, our parents' parents, way back, they fell for everything. They fell for the moon landings. It's not about the flag, if it was flapping in the wind. It's not about the fake pictures of planet Earth in the rear view as the command capsules and stuff were headed towards the moon and Earth seemed to get smaller and smaller. It's not about that. It's about 6 freaking successful landings between 1969 and 1972. That should be enough, okay? If the common sense was where it should be, just the dates is enough, right? Now, a few of us old school, the ones, you hear a few of us screaming and shouting. We're not screaming and shouting because we haven't got anything better to do. We're screaming and shouting because what we scream and shout about, we feel it's important, okay? Now, we all know my go-tos are the speed of light, speed of light is obviously absolute, right? And the Egyptians building the freaking pyramids, okay? All right, bud. Oh, yeah. All right, mate. Dinner, yeah?
Yeah.
All right. The Egyptians and the pyramids. These two, right, are so obvious that it really does smart all over this region. Oh, so obvious, right? There is so much garbage on social media. There is so much trash that people are believing. Look at the chats. Some of the things, it's like, and people are believing it. People, the last generation, born in 1990s onwards, right? 2000 devices, right? You think everything is doable. There has been this lack of hands-on. You think the pyramids, you think the Egyptians, 25,000 Egyptians, you're finding excuses for how 25,000 Egyptians messed about, manhandled 2.3 million 2.5 ton stones. That statement, that's it right there. It should be put to bed because it's stupid. But no, we find reasons. We don't care about the quarrying. We don't care how they quarried even one stone, which was impossible back then, as it would be now. You don't think so? Then get off of your arse, get yourself some copper hand tools, go and find yourself a limestone quarry, and you will not get a single stone out of there with your copper hand tools in your entire life. That is a fact. If you don't think it's a fact, like I said, get off of your arse and go and do it. Maybe grab some of these people that come up with these stupid, pathetic, illogical, common sense defying theories for how the pyramids were built. All of it is a load of garbage. The speed of light, well, it's obviously absolute. There is no delay. That is more than obvious during a solar eclipse, when the sun is directly behind the moon. This cannot be. As you've probably heard me say once or twice, it cannot be, because if there are Mickey Mouse photons traveling from the sun and they're taking 8 minutes and 20 seconds to get here, when that shadow of the moon is being cast by the Mickey Mouse photons, when those photons left the sun, planet Earth turned 2.08 degrees on its axis in that 8 minutes and 20 seconds. So that means when the shadow is being cast, those particular photons, because they took 8 minutes and 20 seconds to get here, planet Earth would have moved out of the sweet spot position. The sweet spot position on planet Earth is not possible with finite light. It's a slam dunk. It's about common sense and logic. But because of the absurdities and the noise, the amount of noise that's going on, you're overlooking this. And I can't whistle, but I will. I'm going to get a whistle today and just come back and do a short, right? I have been here long enough. The pyramids was the first one I started, because honestly, it's just so stupid, right? It is. Kids could believe it, but not adults. Adults shouldn't be believing that 25,000 Egyptians somehow quarried 2.3 million, 2.5 ton stones with copper handles in their bare hands, plus a load of other stuff. Some granite blocks weighing 60, 80 tons. What, are we really that thick that we think somehow, in some dimension, that was possible? Couldn't even be done now. It could not even be done now. The pyramids could not be constructed the way they are now, and that is a fact. All these people now go, get off of your ass and go and quarry just one stone. Don't say, oh no, but I've seen some program, because it's a load of bollocks. Get off of your ass, get yourself some proper hand tools, and go and see what it's like trying to get one stone out of a limestone quarry face wall, whatever you want to call it. You will not get even one stone out in your entire life. You and 100 friends. You don't get a stone out, not with copper hand tools. It's a slam dunk. But we think everything is doable, don't we? I've been, like I said, doing this for a few years now, and a few people are starting to take notice, right? I'm just wondering, maybe it'll be in the next year where a lot of people will go, is that guy still? And what is it he's saying again? Because if you start to listen to what I'm saying, instead of just brushing it off and talking about how fantastic photons are, they don't exist, right? You'll start to realize that what I'm saying, I'm being objective, and all of the facts are on my side, right? All of the facts are on my side. This morning, what I wanted to talk about, it's about light, stars, right? It's something else. What's been happening is, I always say, there's people claiming knowledge that cannot be known. Now, what has been happening is there are a lot of people that are making claims up about stuff that has happened in the past, but it hasn't happened. And because those lies are passing, it's then justifying some of the absurdities that they're getting away with today, right? So they're making crap up, like Roma and all of this stuff in the 1700s. They're making that stuff up. because it didn't happen. And you won't know it didn't happen until you get off of your arses and you attempt these things yourself, right? This is a fact. You're all there with your little devices and your notebooks, and you think your books, you just believe everything that you hear, right? But most of it is lies, right? Now, this speed of light thing, what we're going to talk about this morning, I'm calling it, I'm just tracing back, and I'm spotting the absurdities as I go along, right? I know for a fact that light is absolute. I know that it doesn't take 8 minutes and 20 seconds for the light to reach us from the sun, because it's stupid. It's illogical. We can see the sun up in the sky. 4.6 seconds for a star to radiate its own light, the distance of its own diameter. That's our sun. 1,390,000 kilometers divided by the speed of light, 299,792, gives us a number 4.6. If you divide UY Scooty's diameter of 2.377 billion kilometers by the speed of light, you'll get, what was it, 7,928 seconds, I think. Anyway, it comes down to 2 hours and 12 minutes. UY Scooty, according to the speed of light, takes 2 hours and 12 minutes to radiate its own light, the distance of its own diameter. 2 hours and 12 minutes. I'd be here for 2 hours and 12 minutes. People, it's a shame you cannot see how stupid the things that you're believing are, all right? It really is. Now, this thing called parallax, it's another absurdity. Is it 2 hours? Look, it's a bullshit word, so it really doesn't matter. Parallax. Now, I've got 2 eyes, right? My left eye and my right eye. Now, when I'm looking at that piece of chalk on the ground, if I look for my left eye and then go camera 1, camera 2, camera 1, camera 2, 1, 2, 1, 2, it shifts a little bit. Now, the absurdity is that with that little shift, because if I know the distance between my eyes, look, it just goes on and on. But let's listen to the real thing, okay?
At this point, things got sticky. Planets are pretty far away and look like dots. Our methods for finding distances failed for them, for a while at least.
No, not the 28, but it's only 4 seconds. Time for a whistle attempt. Nah, can't do it.
A story of opportunity.
In the 17th century, Johannes Kepler and Isaac Newton laid the mathematical groundwork of planetary orbits, and that in turn made it possible in...
No, they didn't. No, they didn't. These things are the lies that have been fabricated to justify the absurdities of today. They've made claims of knowledge up. They've made this stuff up. I'm telling you, they've made this stuff up. It didn't happen. And they're using those things in the past to then justify the nonsense that they're getting away with today. It's a slam dunk. A slam dunk.
theory to get the distances to the planets. But there was a catch. When you do the math, you find that measuring the distances to the other planets means you need to know the distance from the Earth to the Sun accurately. For example, it was known that Jupiter was about 5 times farther from the Sun than the Earth was, but that doesn't tell you what it is in kilometers. So how far away is the Sun? Well, they had a rough idea using the number found by the Greeks, but to be able to truly understand this...
See how it goes? Oh, they roughly knew because of something, the Greeks. What? Is that it? It didn't happen. It didn't happen.
Solar system, they needed a much more accurate value for it. To give you an idea of how important the distance from the Earth to the Sun is, they gave it a pretty highfalutin name, the Astronomical Unit,
AU.
or AU. Mind you, not an astronomical unit, the one. That's how fundamental it is to understanding everything. A lot of methods were attempted. Sometimes Mercury and Venus transit or cross the face of the Sun. Timing these events accurately could then be used to plug numbers into the orbital equations and get
Plot numbers into the orbital equations. What? They're good now because they can call the solar eclipses, right? But this stuff, it's BS.
the length of an AU. Grand expeditions were sent across the globe multiple times to measure the transits and didn't do too badly. But our atmosphere blurs the...
Back in the 17 and 1800s, teams were sent across the globe to measure the transits. This stuff, right?
Images of the planets, putting pretty big error bars on the timing measurements. The best they could do was to say the AU was 148,510,000 kilometers.
They look 148 something million kilometers, right? This is what they say it was predicted at. They do this a lot. And then they go, it was really a good estimate considering, because it's actually 150. So they were only X amount of kilometers out. It's just so predictable and pathetic, right?
Plus or minus 800,000 kilometers. That's good, but not quite good enough to make astronomers happy. Finally, in the 1960s, astronomers used radio telescopes to bounce
And this is when it started. I've always said this. The 1960s, our parents fell for the rubbish. Our parents fell for it. Fell for the 2 atomic clocks being 300 billionths of a second out. Yada yada. Moon landings. Just all of this junk that really should never have gotten through the net.
radar pulses off of Venus. Since we know the speed of light extremely accurately, the amount of time it takes for the light to get to Venus and back.
Now, there is no light delay. We're back here again. We know the speed of light so well that we bounce a signal off of Venus, but how? They say they did it, but nobody's ever seen it. This is a thing everybody just believes without thinking to ask how. And because of the devices, you just think all of the information is at your fingertips. But most of it is BS. There are a few names that have come out in the last 6 months that I've heard. Oh, such and such in such year invented this. And I'm going to start going through the encyclopedias again. Don't forget something, folks. This is another thing. I've got printed books here. You've got Google. Google and NASA have been working together. Alexa, how long have Google and NASA been working together?
From techspot.com, internet giant Google and NASA have been officially working together for more than a year.
2005. Alexa, what year did Google and NASA start working together?
From spacenews.com, since signing the Memorandum of Understanding in 2005, NASA and Google have begun collaboration on several joint projects.
She's a liar. 2005. That's 20 years. Wake up, people. Wake up. Our parents fell for it. It passed on to the kids, and the kids have fallen for it. And there are only a few people left screaming the obvious. You should maybe start paying attention. You really, really should, because this stuff is horseradish.
Could be measured with amazing precision. Finally, after all these centuries, the astronomical unit was nailed down. It's now defined to be 149,597,870.7 kilometers. So there. The Earth orbits the Sun on an ellipse. So think of that as the average distance of the Earth from the Sun. Knowing this number unlocked the solar system. It's the
The number 150 million kilometers, unlocked the solar system. It unlocked the stars because now we know the distance to the sun. So we can use that as a yardstick, if you will.
The mental meter stick of astronomy and the scale we use to measure everything. Having this number meant we could predict the motions of the planets, moons, comets, and asteroids. Plus, it meant we could launch our probes into space and explore these strange new worlds for ourselves, see them up close, and truly understand the nature of the solar system. And it's even better than that. Knowing the astronomical unit meant unlocking the stars. We have two eyes, and this gives us binocular vision. When you look at a nearby object, your left eye sees it at a slightly different angle than your right eye. Your brain puts these two images together, compares them, does the geometry, and gives you a sense of distance to that object. And you thought your teacher lied when she said math was useful in everyday life. We call this ability depth perception. You can see it for yourself by doing the thumb thing. As you blink one eye and then the other, your thumb appears to shift position relative to more distant objects. That shift is called parallax. The amount of shift depends on how far apart your eyes are and how far away the object is. If you know the distance between your eyes, we'll call this the baseline. Then you can apply some trigonometry and figure out how far away the object is. If the object is nearby, it shifts a lot. If it's farther away, it shifts less. It works pretty well, but it does put a limit on how far away we can reasonably sense distance with just our eyes. Stars are a bit beyond that limit. If we want to measure their distance using parallax, we need a lot bigger baseline than the few centimeters between our eyes. Once astronomers figured out that the Earth went around the sun rather than vice versa, they realized that the Earth's orbit made a huge baseline. If we observe a star when the Earth is at one spot, then wait 6 months for the Earth to go around the sun to the opposite side of its orbit and observe the star again, then in principle we can determine the distance to the star, assuming we know the size of the Earth's orbit. That's why...
In principle. Now, first of all, is the sun not moving? Don't they say? I'm using their information. So, how accurate? Let's say January and July, okay? So, in January, you take a look up at a star, right? And you go, oh no, let's go for this middle one, right? And you wait 6 months. 6 months comes around, you could try it. This is what I mean. Get off of your arse, get out there tonight, date, you could recognize a couple of stars, take a look at a star, and then 6 months later, set your alarm when you're on the other side of the sun. If that happens, look up and work out the parallax angle. See how you go. You'll go exactly as Romer went in 1776 when he detected some kind of mysterious light delay. It took longer and longer for Io to appear from behind Jupiter as Earth moved further and further away in its orbit around the sun. It was put down to it takes longer for the light to reach good old Romer's telescope. It's just a load of bollocks. It didn't happen. For those of you that say, get off of your arses, check out a few stars, check out Jupiter in the night sky, and then come back and say that it happened. It didn't happen. These things are bullshit, all right? They are bullshit. Let's let this guy carry on this absurdity.
Knowing the length of the astronomical unit is so important. The diameter of Earth's orbit is about 300 million kilometers, which makes for a tremendous baseline. Hooray! Except, oops, when stars were observed, no parallax was seen. Was heliocentrism wrong? No, it's just that stars are really and truly far away. Much farther than even the size of Earth's orbit. The first star to have its parallax successfully measured was in 1838. The star was 61 Cygni, a bit of a dim bulb, but it was bright enough and close enough for astronomers to measure its shift in apparent position as the Earth orbited the sun. 61 Cygni is about 720,000 astronomical units away. That's a so...
Before electricity, all of this done, right? To believe this, folks, they had no proper timekeeping devices. They had no electricity, no anything computerized. It's just a load of rubbish. Our parents fell for it. Our grandparents fell for it. And some of them are probably even teaching it, not knowing that what they're teaching is actually horseradish. These things didn't happen. If you don't believe me, get off of your arses and just try some of the BS that they keep telling us happened. You won't be able to.
Crushing distance, well over 100 trillion kilometers. In fact, that's so far that even the Earth's orbit is too small to be a convenient unit.
So now, these stars, this is how they measured the distance, right, are just too far. This baseline, it's not big enough. The sun moves, doesn't it? The sun moves. So how accurate? When Earth is here, in 6 months, when it's over the other side of the sun could be over here anyway. It's just all a load of rubbish.
Astronomers came up with another one, the light year. That's the distance light travels in a year. Light's pretty fast.
No. Light years are a myth. If you're seeing a light source in the night sky, the reason you are seeing that light source is because it is powerful enough to radiate to your eyesight from exactly where it is. That is why you're seeing it, because it's powerful enough. If it's not powerful enough, you don't see it. That's it. If you don't see it from the onset, you'll never see it at all. Proxima Centauri, we've been through this. Proxima Centauri is the closest star to planet Earth apart from the sun. Why can we not see it? If every single other star in the universe disappeared, and the sun disappeared, and it was only us and Proxima Centauri in the night sky, we wouldn't see it. How is that possible? The only star, if it was the only star in the night sky, we wouldn't see it. Why? Because it isn't powerful enough to radiate its light so that our eyes can detect it. Is it not just common sense and logic? It's not powerful enough. The light is not going to start traveling towards us anytime soon. It will radiate its light to a certain distance at absolute speed, and there it will stop. It will not radiate past a certain distance. That's why we don't see Proxima Centauri, Barnard Star, and what was it, Wolf 359, I think it was. Guys, if you're seeing a light source in the night sky, the reason you are seeing it is because it is powerful enough to be seen. Pure common sense and logic. All of this is just trash.
And covers about 10 trillion kilometers in a year. It's a huge distance, but it makes the numbers easier on our poor 8 brains. That makes 61 Cygni a much more palatable 11.4 light years away. Astronomers also use another unit called a parsec. It's based on the angle a star shifts over the course of a year. A star 1 parsec away will have a parallax shift of 1 arcsecond, 1/3600th of a degree. That distance turns out to be about 3.26 light years. As a unit,
1/3600th of a degree. Okay, there are 360 degrees in a circle. And 1 parsec, so you've got 90, so that means 0, 90, 180, 270, and these are degrees, so you've got 0 and 360. In each of those individual degrees, it is split into 3,600 partitions. So basically, we have 360 multiplied by 3,600. Alexa, What's 3,600 multiplied by 360?
3,600 times 360 is 1,296,000.
Now, so what we have is, instead of 36 degrees, we have 1,296,000 partitions. So use those parsecs to work out how far a star is away. If you believe this, it's just a little bit silly.
Of distance, it's convenient for astronomers, but it's a terrible one if you're doing the Kessel run. Sorry, Han. The nearest star to the sun we know of, Proxima Centauri, is about 4.2 light years away. The farthest stars you can see with the naked eye are over 1,000 light years distant, but the vast majority are within 100 light years. Space-based satellites are used now to accurately...
Are they space-based satellites? Why is it, if light really does travel like the stars, why is it that we're only seeing, like here's Earth, right? Why is it that we're only seeing stars in a certain region? If all of this light travels forever and ever, well, Proxima Centauri obviously breaks the mold. It doesn't. Or Barnard Star, or the Wolf, 359. It doesn't either. Why are we only seeing stars in the local neighborhood? It's almost as if, it really is almost as if we're only seeing the stars that could be visible to us, the ones that radiate absolute light, the ones that are powerful enough to radiate their light, that we can detect it. Anything further than that, we don't see them, do we?
We find the distance to hundreds of thousands of stars. Still, this method only works for relatively nearby stars, ones that are less than about 1,000 light years away. But once we know those distances, we can use that information on more distant stars.
Oh.
How? Well, like gravity, the strength of light falls off with the square of the distance. If you have two stars that are the same intrinsic brightness, giving off the same amount of energy, and one is twice as far as the other, it will be 1/4 as bright. Make it 10 times farther away, it'll be 1/100th as bright. So if you know how far away the nearer one is by measuring its parallax, you just have to compare its brightness to one farther away to get its distance. You have to make sure they're the same kind of star. Some are more luminous than others. But thanks to spectroscopy, we can do just that. A star's distance is...
Of course! Enter spectropsy. Spectropsy. Whatever. Listen, it's... You know what that is? It's like dark energy. Dark energy. Something that's introduced to help explain something else. Hypothetical rubbish. That's what they do. They just keep coming up with words. All of it. Your parents fell for it because their parents fell for it. And now you're falling for it. And there are a number of us out here screaming. I'm hoping that I've been here maybe long enough for a few more people to start paying fucking attention to what I'm saying. Okay?
is the key to nearly everything about it. Once we know how far it is, and we can measure its apparent brightness, we can figure out how luminous it is, how much light it's actually giving off. And its spectrum tells us its temperature. With those in hand, we can determine its mass.
Just shut up. It starts from the beginning. If all of these dominoes have all fallen, haven't they? But if the first one was bullshit and it's taken out of the picture, the others don't fall. Apollo 13, it's obvious it never went to the moon. That means 14 didn't go. 11 or 10 even, right? The one that took the the photographs that were then passed on to Neil and Buzz and Michael Collins, right? It's obvious that it didn't get up there, it didn't descend and put the anchors on and stop about 9 k's or 9 miles from the moon, orbiting at that speed, and took photos and then cranked back up, met the command capsule and then booted home, time for scones and tea. And that was in May 1969, I do believe. June, July, a couple of months later, Apollo 11 goes up with the photographs and landed successfully. Are we this dense, right? The speed of light is absolute. The speed of light radiating from the stars and the sun, it's absolute light. We know this because during a solar eclipse, there is no delay. The sun is directly behind the moon and it cannot happen if Mickey Mouse photons are involved. This is a fact. Since I've been doing this, nobody, even the astrophysicists, are avoiding me because there is no logical answer, right? This stuff that you're believing is bullshit. All of it, it's BS. Now, I'm going to try, for the hell of it, through that tripod, I'm going to try and feed this stick. I'm going to call it now, right? Not happening. I'll see if chance of foam might fall off, chance I might get like a bullseye and get right through the legs. I missed. I'll be back later, peeps, with more absurdities. 8 minutes and 20 seconds, 4.6 seconds to radiate its own light the distance of its diameter. What is wrong with people? Later, peeps.